everyone, Joanna Wilson here for my OCR A-Level Chemistry Manual. Today we are going to be looking at Section 7, Rates, Equilibrium and pH, and we're focusing on acids, bases and buffers.
Just wax your lips.
The outcomes for this session are to extend our knowledge from the AS spec and describe the concept of a Bronsted-Lowry acid and base, to describe the role of hydrogen ions in reactions between acids and bases, to define the Ka and its relationship to pKa and the pH, to calculate pH for strong and weak acids, to explain some limitations of using approximations, and to describe how a buffer solution forms and how it can control pH. We also are going to be looking at sketching pH titration curves for strong and weak acids and interpreting their shape. So let's dive straight in because there's a lot to cover. So a Bronsted-Lowry acid is a proton donor and a Bronsted-Lowry base is a proton acceptor, and an acid that reacts with a base is often called a conjugate acid-base pair. So as we can see on here, the reversible reaction between an acid and a base, and also the pairs that are going on. So strong versus weak acids. A strong is one in which fully dissociates when placed in solution, and a weak acid is one which does not fully dissociate but sets up an equilibrium which is weighted far to the left. Now Ka is the acid dissociation constant and represents whether an acid is strong or weak. So acids can be monobasic, dibasic and tribasic, and this refers to the total number of hydrogen ions in the acid that can be replaced per molecule in an acid-base reaction, and we've got an example of each. Now I briefly spoke about this in the AS spec, but what is the definition of a pH? So when acids dissociate in solution, they're split up into hydrogen ions and negative ions. And the definition of the pH is the minus log to the base 10 of the concentration of those hydrogen ions. So a greater concentration of hydrogen ions results in a lower pH and is typical of a strong acid. So the acid dissociation constant then, consider this acid-base reaction. From the last section we learned about the equilibrium constant and it's set up pretty similar. So it's the concentration, but in this we assume the concentration of water to be constant, and it's an approximation as we assume such a small amount of acid is dissociated when we're looking at our weak acids that it doesn't affect the concentration of the acid in the equation, and this doesn't stand if we have more than 5% dissociation for those weak acids, so we need to use a quadratic equation, and this is beyond the specification. We just need to know that we are using approximations and there is therefore some limitations of this. Thank you so much for watching this teaser video for the OCR A-Level Chemistry Manual. You can now click the link download to download the full manual. Please check it out now. Keep smashing it, and remember, anything is possible if you just work. Bye!